My name is Robert Ranishevsky. I am a controls engineer at ATS. I do design and debug for hardware, software, and vision systems on our machine. So with an asynchronous machine, each station works independently. It can begin a process and finish the process independently of another station. Essentially, a part can come in, the part gets worked on, and it exits as quickly as it can. So the benefits of an asynchronous system are that it can be built quickly, and debug efforts and service efforts and maintenance efforts can be focused on one place without having to necessarily always have to look at the system as a whole. It breaks down a large unit into an individual, more manageable unit. Most common challenges that you have on async systems are when you have multiple moving components, parts that need to handshake one another, and eventually you run into problems with cycle time. The easiest way to overcome cycle time issues is when you have SuperTrak, because it's a linear motion technology by ATS that allows the controls engineer, or whoever's really using the software to interface with that system, to speed up and slow down pallets within what's physically possible. We have multiple variants running on this machine. It's a family of products. There are 10 of one variant and 1 of another, but the geometries are very different because of how SuperTrak works and how you can change the position of where the linear motion pallets go. Then we can run all 11 variants with one set of nest tooling, and the only thing that needs to change over is one set of robot grippers. One of the coolest innovations on this program is a space-saving trayhandler that we've made here at ATS Chicago. Basically, it allows the operators to load a rack of 7, and the only reason we have 7 is because of ceiling height, trays that will be pulled into the machine, processed by the robots, and then pushed back in. Elevator moves up, process repeats, and it allows you to save space, and instead of going out with some other tray handling systems, we go up. The different teams work together for synchronous machines differently than on asynchronous, because on a synchronous machine, a lot of it is driven by mechanical. It's very, very heavy up front. CAM design is very complicated. You've got to be perfect because it takes a long time if you make a mistake. On an asynchronous machine, controls drives the effort because you have that flexibility. You can focus only on one station at a time, and a lot of those parameters are controlled by something that the controls engineer can directly manipulate. I think we're driving more towards asynchronous now, at least here in Chicago, because it's something that saves a lot of time up front and returns a result more quickly for our customer. It also minimizes rework, especially with SuperTrak. If you get your nest pitch off on a synchronous machine, it might mean that you're remaking every nest. If you mess up the pitch on a SuperTrak, you change a number in a program. In terms of long-term benefit to the customer, SuperTrak is very flexible in allowing stations to be retrofitted in. If you've got multiple lines that do the same product, but future lines have additional stations, SuperTrak allows you to just teach a new pallet target that will be at the same location as the new station. The part that I'm most proud of is the fact that we were able to get all of our top talent on this machine, between having phenomenal mechanical engineers and builders and electricians to put all this stuff together as quickly as possible. Then we've got an entire team standing behind it to get it to where it needed to be, on time, under budget, the way it's supposed to be.